All right, so for this week, we start diving into enemies. Um, so this is a great time to introduce the state machine. You're going to use this or something like it to create your AI, kind of for whatever project that you do. State machine is just another system for doing so, just like behavior trees. Um, So let's go ahead and create. Let's go ahead and create our enemy. I'm just going to make it super simple. We're going to create a little robot. So let us create a 3D object, create a cube. I'm going to call it. So I'm going to zoom in on it. Oh, it is way up here. Let's just throw this guy down. Here we go. This is better. We're going to go ahead and we'll make him a little large. Why not? Let's go crazy. It's a big robot, which is why it's going to try and kill you. So we'll go ahead, cube. I'll make it 2 meters all around. And then attached to our cube, let's go ahead and parent in here another cube. We're going to call this the head. The head should, we'll set this back to normal scale. So we'll just set it at halves since it's now attached to the one, and we'll bump this guy up right about there. We'll change the name of this to robot. And then into our head, we're going to child another object. We'll make it another cube. This is going to be its scanner, how it is, quote, looking. And we're going to increase, where are you? We're going to make it thin. So let's go, we'll call 1.25, 0.25 and 1.25. That way it's all the way around, and we'll just kind of raise it up a little bit so it kind of looks both like eyes and a hat, I guess. Perfect. And then let's go ahead and in our materials, let's create, I'm just going to duplicate the player material. I'm going to switch it to robots. Let's go ahead and change it, its color to a let's set it to black. We'll set that there, and then we'll also, I'm going to actually make it more metallic. More shiny, because it's a robot. It's supposed to be shiny. And then let's duplicate this, and we'll just call this head. And we'll change its color. I'm just going to change the color to more of a gray or dark gray. That looks great. We'll attach that to the head. And then for the scanner, we're going to create 2 colors. Active scanner, and we'll duplicate that and do passive scanner. This will make sense in a bit. Active scanner, let's go ahead and make this a green. Ooh, I like it. And we'll just apply active scanner to the scanner to start with. But passive scanner, let's go ahead and set this to a... Actually, no, let's switch that. Let's make this the green for the active scanner, and then, or for the passive, and then active scanner, let's make that red, because it's dangerous. All right. So we got now a cool little robot. It's going to move around. It even shows up in our mirror, although that's hilarious how stretched out it is. It's fine. And we'll just slide it back a bit. Yeah, that works. Okay, so now what we need to do for the robot is, even if we put together a state machine, we're going to have it move around the scene. But we want it to be able to navigate around objects. We don't want it to like walk through the mirror. So we need to create what's called a through the AI navigation, we create a nav mesh. And so we need to go ahead and add that nav mesh in. So to do that, we're just going to have the robot move around on the floor. So we can select our floor. We can then add a component, nav, just start typing nav. You want nav mesh surface. We can do some other cool things like volumes, obstacles. We'll get into agents in a minute. So we'll just do a surface. This sets up some values. How much of an incline can it go up? How much of a step can it go up? Defining what's walkable, not walkable, what you can jump to. We're just going to go with walkable because it's a robot and this one does not jump. You can set up other agent types. We're just going to go with humanoid. And so once you have that, even though we have nav mesh surface attached, it's not there yet. So we're going to go ahead and hit bake, and then you know it's there if you see that it goes this nice blue color. You want to, I think it's Windows, AI, navigation. If this is not up on your screen, you can do this to bring this up. And so then you can see show nav mesh, right? So we can set it there. And as you see, right, the blue is the nav mesh. That's where it can move around in. And right here, it blocks it. It's not going to be able to walk through that spot. Now, the robot itself should not have the nav mesh around it. So we're going to add a component. So this is going to be our nav mesh agent, right? We want it to travel. So with this, we attach nav mesh agent to it. We can set up obstacle avoidances. How far away does it go? Will it go off mesh? Will it go back onto the pathways? What kind of speed and acceleration does it have? How does it brake? All of this is important. All right, and I think we should be good. We'll find out. I think we're all right with that. It's been a hot minute. We'll get there. We don't have anything that's telling it what to do at the moment, so we will get to that aspect here shortly. All right, so just because we now have a nav mesh surface and we have a nav mesh agent, we don't have anything that's going to move on its own. it needs to now be able to make some decisions. And that's where our state machine is going to come up. So I'm going to start this by in the scripts folder. We're going to go ahead and create a new folder in here just so we can have it separated. We'll just call it state machine. That way all of our state machine scripts are in one area. All right. So what we need to do with this is we need to first set up the overarching state. Like, how is this going to actually work? So we're going to go ahead. We'll just start with the mono behavior script. It's going to change from here. Let's call it robot state. We're going to modify this a bit. We don't actually need the mono behavior, but we'll remove that in a minute. Just remove it now. Why not? Let's get rid of it. It's out. Instead of being just a regular class, this is actually going to be an abstract class. We're using this to define other things. So we do not also need any start or update because that is not of importance. This is just a script that is going to help set up how the robot state machine works. So we're going to create a protected variable, protected, and we'll call it the robot state controller. You're going to see a lot of red lines for a little bit until we get all the scripts and everything put together. Robot state controller, we're going to call it RSC for robot state controller. Then we're going to set up the different things that will happen in each one of the states. So we're going to start that with a public abstract variable. It's a void, and we're going to check transitions. Transitions, gotta spell transitions right. And it's a function. All these are functions that'll be called. So the abstract two of these are the check transitions and the public abstract void act. These are the two that are going to run every time. So no matter what state we're in, we're going to always check the transitions. So seeing, should we stay in this state or should we go to another state? If we are in the right state, if we don't transition, we do our actions. If we do transition, it will skip the action. But for the most part, these are the two that are going to run time and time again. And then we're going to add two more functions that we're going to do. These are going to be virtual void on state enter. And we're going to do that. And public virtual, can't type, void on state exit. So these two are going to run once per state. The on state enter runs when the first time, the first frame that state is running. And so you can implement different things. In here, we're going to actually change that scanner color depending upon what the robot's doing. And then on state exit, if there's some information that needs to get passed upon moving from one state to the other. Those don't always have things in them, but they're there if needed. And then we finish out this robot state with public robot state controller RSC. Once again, it's underlined, we haven't set it up yet. this .rsc is equal to the RSC. All right, save it. Oh, all this we don't need. Let me clear some of these out of here for the moment. Previous scripts. All right, so let's go ahead and set up our robot state controller. So we've got this in place. We're going to come back here. We're going to create. Now we do want a mono behavior. And this is going to be robot state, oh my goodness, controller, just like we had in our robot state. All right, so now that we have this, look, it's amazing, the red lines go away. For this, we want to definitely make sure we are using, we might add a couple more later, Unity Engine.ai, right? We're going to be using AI for this, specifically, if nothing else, for our nav mesh. All right, so we are going to set this up that the robot is going to navigate this environment in a working mode. If the player's watching or if the player's too close, the robot is going to work, and the moment that it's either out of eye shot or is far enough away from the player, it's going to take a nap because this robot is overworked. So that's what we're going to set this up for. We can add much more. We can add shooting, we can add patrolling, we can add lots of different things to it. But we're just going to start with that for this example. So we want to get a reference, and all of these, for the most part, are going to be public, because these need to be public because they're going to be accessed by other scripts. All the state machine scripts need to talk to each other. And you'll see that as we go through. So we're going to set this public game object. We need a reference to the player. And we need a reference to the scanner that's on the robot. So we need those two game objects. We need a public robot state. We need a reference to that so that we can know what is the current state of the robot. We're going to have it move around in its cleaning, so let's do a public. We're going to create a list of transforms, and we're going to call those destinations. That's our list variable, so we'll set this to new list transform. We need to set up what our nav mesh agent is, because that's what we're going to use for moving around. This has got an error. It threw this end unit. That's not what we want. We're going to instead using system.collections.generic. That should fix that. And it did. Fabulous. We need a reference to the nav mesh agent, which is the robot. So nav mesh agent robot. We need to know what its current destination is. So we're going to do a public transform current destination. Where's it going? What's it shooting for? And then we're going to do a public, and we're going to do material. And this is, we're going to do red and green. These are our scanner colors that we're going to throw in there, so we can change the color of scanner depending upon what action it's doing. Okay. So once again, we're going to have a bunch of red lines in here as we go through, but it's all going to make sense as we get there. So on start, we're going to need to set that the robot, which is our nav mesh agent, is equal to get component nav mesh agent, right? We've attached that to our robot. Let's come in here, double check, we should be there. Robot has nav mesh agent, right? So we're going to end up putting the robot state controller script on here, which we could actually just go ahead and do that now. And so we'll populate these a little bit later. So that's why we're going to be able to just use the get component to reference that. If it wasn't on the same thing, we'd have to say which game object it's a part of, but it's there, so we're good. We're going to leave a space here because we're going to add one more. We're going to set the state. We need to set which state we are coming in at. Actually, we're going to wait because it's just going to be annoying for a minute. Let's go ahead. We need an update. In the update, we are going to run the same thing over and over and over again, which is current state. So what is our current state? It's going to either be working or sleeping. So for whatever state we're in, we're going to run check transitions, right? We want to check our transitions first. Should you still be in this state or not? And as long as you're still there, we're not going to skip ahead. We're going to run through our update. And so our current state then goes to the actions, so act. Once again, we only are running so these are our two that we're running every update unless we break it with the check transitions. And then the on state enter, on state exit are only going to apply when we're changing states through the transitions. So we only need these two in here. And so let's go ahead and real quick, so we can fill in some other things on our start. We are going to public void set state is what we're going to set this as. And we're going to set this as robot state because we're going to pass what state it is in here. We'll call RS for robot state. And so we want to run some checks. So as long as if current state does not equal null, right, there is a state that's set. We are going to current state dot on state exit. So if we're changing the state, as long as it is in a state, right? When we first boot up, the robot doesn't have a state, so we're going to actually set the state. So to whichever state we're starting with, which will be working. Could be sleeping. We're going to choose working. But so we're going to go through and set the state before we set, and set state is going to happen every time we transition, right? We're going to set the new state to, if it's from working, we're going to change it to sleeping. And so we do that as long as it's in a state, which would be working, we're going to run the working state on state exit first. Then we're going to set the current state to equal whatever robot state we are passing in, right? So if we're passing in sleeping, now the current state is going to be sleeping. So then we run this again. As long as current state is not null, right? We want to just make sure that for whatever reason the state is there. we're going to now run the current state dot on state enter, right? So if our current state is working state, we have a state, so we're going to run this. So we're going to say working state on state exit. So finish, close up whatever we need to do from working state. Set the current state to the new state. So we're changing from working state to sleeping state. So now we set the current state is sleeping. And so once again, double checking to make sure there is a state. As long as there is, which we know there is, we've passed in sleeping. Now it's sleeping state on state enter. All right, hopefully that makes sense. It's just the flow through it all. And so now what we can do is we can set state. We're going to give a space because I got one other thing to go in here. New robot, which we don't have this there yet, so it's going to put a red line. Working this. All right. Once we put in the robot working state, this will go away. But we are setting the first state on start to robot working. So when we first come through, we're not going to run an on state exit because we don't have a state. We set the current state to working, and then we do the working on state enter. Okay. Now, we have that, but where are you going? What's the robot doing, right? So in the working state, we are moving around. So we're going to do a public transform. So we're going to receive information out. So public transform, we're going to call this random. Ooh, that's not how you spell it. Random destination. All right, random destination. It's underlined because by making this not void, it needs something returned. And so until we make sure that we're returning something, it's going to be a problem, letting us know that we need something there. So if destinations, my goodness, I cannot spell destinations, destinations count is greater than 0, right? So we've got here our list of destinations. These are transforms. These are going to be the destinations that we can go to. So if it's at least not 0, we're going to set variable random destination equals random dot range from 0 to the total destinations available. It's just going to kick back a random number there. And then we're going to return destinations random destination. So we're passing something through, right? Which it's a transform. It has to be of a type transform, which destinations are of a type transform. But we still have a red line. And the reason for that is there is a case where the destination count is 0 or less, right? Not really less than 0, but it could be 0 if we haven't set any up. So this will always say it's a problem because there is another option. And so what we'll do is cover that by adding return null. So if this doesn't work, we're going to return null. If it does, we're going to return the destination number. And so with this, we can now put that our current destination is going to equal random, whatever we get out of random destination. Right, so we're setting the current destination. Current destination is a transform to the transform that is spit out of our list of destinations. And that sets up the main core of the controller. A lot of more stuff can go in here. Shooting, dying animations, all those things can easily go in here as well. But this is what's going in here at this point. Okay, we've got a red line. Let's get rid of the red line. So we're going to come in here and we're going to create another script. I'm just going to go with the mono behavior. We'll change it up as we go. We're going to call this robot working. And you know, might as well while we're here, let's just go ahead and create the final one, and we're going to call this robot sleeping. Spell sleeping correct. Okay, let's open them both up just so we don't have to worry about them. Okay, once again, we're going to be using Unity Engine.ai because we're using artificial intelligence in there, and because we've got our list, we want to go ahead and we'll just add in our using system collections generic. That should cover any other things that we need. And so since what the robot working script is going to be doing, the state here, it is going to be using all the stuff that we set up in our robot state. So we have this abstract class, and now we're going to go ahead and call out to it. So instead of mono behavior, we're going to call this robot state. All right, and we've got a red line because we don't implement the check transformations, the actions, or anything else. So, all right, we are going to first, oh, and it also says it does not connect to the RSC. So let's handle that first. We don't need the updates and the start. Goodbye. So we're going to public say that robot working, our robot working class is part of the robot state controller, which is our RSC, and it's using the base RSC that we set up previously here in our robot state, right? We've set up this aspect here, which is what we're using here. So now you can see that we got rid of that one problem. We're going to next put in a public override void on state enter. It's always going to throw some stuff in there. Just delete it. We're also going to, I usually put these in the order that they're going to happen. Does not have to be that way. It just makes it so much easier for me to keep track of what's what. We're going to also do a public override void check transitions. And then, so we enter the state, we check the transitions. We're going to override void action. So, right, if we make it through, then we're going to do an action or actions. And finally, override void on state exit. So once our transition has happened, right? So when we transition to the robot working state, we run the on state enter, do something when we enter that state. We check to see if we should still be in the state. If we are, then stay in the go to the action, and then this becomes our loop. Check the transition, action, or act. Check the transition, act. Until such a time as check transitions moves us to a new state, right? In this state, it would go to robot sleeping. At that point, we skip the action and immediately go to exit. All right, let's save that. And so what we're going to do when we're working, we want the scanner to be red, right? We've got our, gotta pick the right one. We have our red and green materials. We also have our reference to our scanner. And so in working, what we'll do, RSC allows us to call our robot state controller. And so we have a reference to that. And so now we can access, because we set everything up as public, the scanner. And we can get the component of the scanner. We're going to get the renderer. And we're going to set the material to equal to, once again, we're making our call back to the robot state controller, and we're going to call back to red. All right. And the other aspect of this is our robot, when it's sleeping or when we start up, it's not moving, right? I mean, I guess we could set it up to sleepwalk, but this is not that level of AI. And so we need to tell it to get going. And so to do that, we're going to call back to our robot state controller. We're going to get component nav mesh agent, and we're going to set is stopped to false. Right? It's not stopped anymore. It is now moving. Let's get that guy going. All right. Now that it's moving, we need to check and see, should we be there? And so we're going to do our RSC scanner. And we're going to transform dot look at. Look at finds an object, whatever it is. In this case, it's going to be the player. I'll see that in a second. And it's going to look at that direction. It's going to rotate itself around so it is looking at it. And so look at the RSC player, and we want its transform position. Where is the player? Look at it. Now we need to see if it sees the player, right? It wants to see if it sees the player. And so we do that through, in this case, we're going to do it through raycast. So we'll set up raycast hit. And we'll do the physics. So if physics dot raycast, which is going to be originating from the RSC scanner, position, transform position, and it's going to be targeting, or in the direction it's going to be going from there is forward from the scanner transform dot transform direction vector 3 dot forward. So what this is doing is it is taking the raycast, it is starting it at the scanner's position, and it is going now, because we're looking at forward is where it is currently facing through the look at. So it's going to be pointing to the player forward, and then we're going to get an out. If we hit something, it's going to come out into our hit raycast hit variable, and we're just going to let it go forever. So math f dot infinity and beyond. Oh, it's fallen off my screen. Let's bring this over. Infinity. All right. So now if hit what it collides with, collider.gameObject, so the game object it collides with, and the name of it doesn't equal, we'll call it player. So if it hits something other than the player, it means it can't see the player, which means it's time for a break. So in this case, we're going to then, like we've done before, we're going to set the state. We're going to call back to our robot state controller. We're going to set the state, new robot sleeping, just like we've done before. This is going to show red because it's not fully set up yet. Actually, we can save a little bit of time. Let's cheat. We're going to copy all of this. It's not too filled in yet. Go to our sleeping. We'll just go ahead, change the state to robot state. And we're going to paste all of that. We need to make sure we set this to robot sleeping. We're going to delete, actually we're going to leave those because let's just change them while we're here. We're going to delete the last one. And we're going to now change this to green, right? So it's not actively moving and doing anything. So we're going to set that scanner to green from red. And we can actually get rid of all of this because that's not going to matter to us. All right, let's save it. And now if we go back to working, look, we got rid of our red line. Okay. So as long as if the robot, when it looks at the player and the raycast comes back and hits the player, it's just going to keep working. When it kicks back something that is not the player, it's going to go ahead and attempt to sleep. So now we're going to change the state to that, which means we skip the action and we go to the on state exit. And so what we'll do here for the on state exit is we're going to leave it blank. We don't have anything to do at the moment. We could put a debug line in here if we really wanted to, but right now we don't need to worry about that. And so, but if it is seeing the player, right, it sees the player, it's going to go the action, and we're going to keep in this loop. So what's it doing in this case? We are going to be moving around, working in different areas of the playing field. So we're going to see where it is in relationship to where it's going. So distance, we're going to get a vector 3 called distance of the type distance, and we're going to get the position of the robot. So we'll get its transform position, and then we want to know how far away is it from the current destination's position, which is a transform. So we can just, if it's a transform, we can just call the position. And so if distance is less than, we'll call it 3 meters from it. So it's gotten really close to the spot it's supposed to be working. We're going to go ahead and change the current destination to a new destination, and it's random, so we're going to call out to the random destination function. If it hasn't gotten close yet, it's just going to continue on to it, and we can do that through RSC robot, which is our agent, dot destination is equal to RSC current destination position, right? So start making your way to that. Your destination through the nav mesh is whatever that current destination is. All right, we have now everything that goes into working. We could have something up here of if the destination, if you're at 3, stop moving for a little bit. We could have it rotate around in a circle a few times, whatever it is, and then move on to a new destination. There's lots of things that can happen in this act function. So it can be as simple or complex as you want or need it to be. We're just going to keep it simple for this example. And so, perfect. So let's finish up the sleeping script. We're going to, with this, for checking the transition, we just want to see if the player gets close to the robot to like scare it to awake. And so we're going to run just like we did before. We're going to get the distance between them. So vector 3 distance. We're going to get the transform of the robot position and that of the player. And then we'll say if distance, is less than, let's call it 5 meters, 5F, because it's a float. We're going to, this is where we're going to check our transition. So if it is less than that, go ahead and set state back to new robot working. Let's see. So if it's asleep and the player gets close to it, it's going to wake up. Otherwise, it's action, and we don't have to have this way. We don't need it to run every time. I just wanted something in here to show you how it works. So we're going to have rsc.getComponent nav mesh agent dot is stopped is true. So if it's sleeping, it's just not moving. It's stopped. We don't. Once again, we do not need to set this up here as an action, but I have nothing else action-wise to do. This would make more sense to go into the on-state enter. So when we enter, it could even go into the robot's working exit. When we stop working and go to sleeping, actually you wouldn't want it on working because working could transition to something else. We wouldn't want it to be there. So on sleeping, it would make sense to just have this at is stopped as true on the on state enter, right? Because we're sleeping, we're here, and then we could have the scanner rotate or something like that. But we're just gonna put something here so it's there. And once again, we're not gonna worry about changing anything on exit. Okay, we've got that all set up. We're going to now plug in a few things. So robot needs a reference to our player. We're going to get the reference to our scanner and bring that in. We'll do destinations in a minute. Robot gets robot. Current destination is going to be none right now. We don't have a current destination. Remember, we're setting that in our right in our start, so we don't need to implement that at the moment. And we need to get our materials. So we've got our active scanner is red, and passive scanner, probably should call this red and green, but of course I didn't do that. Passive scanner is our green. All right, we'll save that for the moment. Once again, we're using we're not using distance for it to judge when to fall asleep. We're using can it see the player. So let's just real quick create 3D object, cube. Where are you? It's over there. Let's go ahead and make these let's do 20, oops, 20 by 5, one's fine. Oh, heck, let's make them a little thicker. 2. And then 5, so let's set this to 2.5. Okay, and so let's just move a few of these. We'll just call them walls. So we got one wall over there. Duplicate it. Let's do 6 walls. 1, 2, 3, 4, 5, 6. So we'll move wall 1 and we'll rotate these in a minute. Does not matter where you put these in the scene. I'm going to just put them here. That's good enough. I'll move this one a little bit because, you know. And then I would just rotate them a little bit so we have some different look and feels. I don't know. There's no right or wrong to this. So however you want to do it is great. Sure, that looks funky. And then I'm going to do that, and then I'm going to actually move it a little bit closer. Okay, so we've got our walls. Now, if you remember, we have a list of destinations, and we need to set what those are. And so what we're going to do is let's do 4 destinations. So we're going to use an empty game object. We'll call it destination. And so destination, we'll set the first destination. It's kind of over here. Duplicate it. We can set the second one over here. Sure. Duplicate that one. We can put this one just here and I don't know, there. That's great. Okay, now we've got destinations. We need to get these into our destinations. The easiest way to do that is to, if you see up here in our inspector, we have a lock. If we click lock, it's going to allow us to click on things without it changing anything. And so now we can just select all 4 of our destinations and drag them here to destination in the inspector, and it just populates it. So nice and easy. Don't forget to unlock it again, which will take care of all that. Okay. Now, if all goes according to plan, which I make no promises, we are going to, we need to, hold on, walls need a nav mesh obstacle. And we'll carve out from there. So by doing that, now you can see we have our little buffer around it. All right, now let's see if it begins working. We'll hit play, and we'll problem solve from here. That's what I feared was going to happen. Okay, stop. It's stuck into this. It is not supposed to be cut out around it. So let's go ahead. I'm going to rebake the floor. Now we should be good. There we go. And so now it is moving around. We're going to just follow it. And now you can see we're out of its line of sight. Its scanner has rotated. Probably should make that a little bit bigger. It is sent it out, and you look, we get right in that line of sight. It is not seeing the player. It's kicking back that it's seeing the wall. So it has said, I'm taking a nap. And so now we can come here, sneak up on it, and, oh, it says, oh man, you found me. I want to get some work done. Oh no, stop following me. I don't like it. It's lost its sight. Sees us again. Line of sight. Right, whenever we get out of it. Got a little too close to it. With this, we probably want to increase. As you can see, it's kind of cutting through the wall. So what we want to do with our walls is we're going to want to go ahead and increase that. Let's go. That was way too big. So let's say 1.2. You can see that box around them. So on this, we want actually our Z's to be a little bit bigger. We can actually bring this down a little bit. We just want it to be far enough away that it's not actually like pathing through. There should still be enough room for it to move around. We can also do this with our mirror. Which is just the wall here. So we can add the component obstacle, carve out its space, zoom in so I can see a little bit better, and we've got a little bit more, and I'll give it a little bit of room around it. All right, and then let's go ahead, and then we can change for sleeping. Let's let it not sleep so quick, or can't sneak up as close. Let's set it to 10. He can't see us because it's hiding behind the mirror. So we can move up here. Oh, look up again. It's heading off. We can clear that space there if we needed to. And then we see it disappears again from our view. For some reason that wall did not get set to the right size. That's fine. But as you can see, so with this, we now have a state machine. This is how a state machine works. We can add an infinite number of states. I mean, I'm sure there is technically probably a finite number because there's only so many options and things that you can do. But with this, we have so many different states that the player or that the robot has, right? So this could be robot attacking, robot running away, robot freaking out, robot healing, robot whatever it is, right? There are different states. So all you're going to do is you're going to add new scripts to this, and you're going to go through the same thing for each one. You're going to have an on state enter, check transitions, action, on state exit. And all that's going to flow and go through. Anything that is going to be like specifically controlled by the robot, you want to have run here in the robot state controller for the most part. And so then you're just calling that state or calling that function through the state. So hopefully that this has been helpful and definitely is going to provide you a good basis for your boss fights and for many of your individual game projects. So that's it on this one, and until the next one, I'll see you later.